So to give some context, when penicillin was first discovered, it was called the super drug because it would wipe out all bacteria so quickly. But currently the state of antibiotics is so bad that it is said that it will set medicine back to the pre-antibiotic era, back when antibiotics weren't discovered at all, if the problem of antibiotic resistance is not solved. So I am very set on solving this problem, or at least helping solve this problem, because antibiotic resistance is an unsolvable problem, but it could be made a lot cheaper and accurate. So Google's AlphaFold used data sets like protein data bank and other protein structures data banks to solve the protein folding problem. Now, bacteria, when they evolve resistance to antibiotics, you have to understand that the binding sites on these bacteria are also protein structures, and one of the main mechanisms of evolving resistance is changing the structure of the binding site, which a platform like FRosalind can detect when the structure of the binding site is changing. So we are training the model currently on resistant database. This has all the resistant genes and the products and the associated phenotypes. Once we get the phenotype, we identify the bacteria that is causing the disease, and this is binding DB. It gives us the exact drug that we can use against the bacteria as well. It could give you the exact compounds as well. There are a few different things we are trying with this database to be able to rank compounds accurately for drug discovery. This is currently being done, by the way. This is not something new, but the new thing in FRosalind is that it uses differential geometry directed training. This is the paper that I got somewhat inspired from for directing the training using differential geometry. I am in talks with some of the researchers that have worked on this paper, but also we are adding something new onto what this paper uses as well, which is we are looking at the binding site structure while also looking at the sequencing data. This paper is solely about looking at the differential geometry of the structure, but if you combine both the things of looking at the structure, the current models already do this, by the way. The current models that the researchers use in lab, they look at the sequence, but they do not look at the structure right now. But this is a way to look at the structure, and if you combine this with looking at the sequence, you get a far more accurate model, and this model could predict antibiotics. And there's something called there's a window, a period in time when one bacteria, when it's been exposed to one antibiotic, it grows less resistant to some other antibiotic, and this window could be used effectively if doctors use rapid phenotyping, which is when a bacteria is growing resistance to drug A, drug B that it is losing resistance to can be introduced at the same time, and it could effectively wipe out the entire population if this is done well. So this is one of the main things we are solving for, to help chronic patients that have developed chronic infections and diseases because of being prescribed wrong antibiotics, to help them solve their infections quicker and at scale in all hospitals. Thank you.